This is on page 4 of your note packet, sample number 2, using synthetic substitution to evaluate. And we did one of these in class on Monday, but here is another sample to help you out with the assignment. So when you want to do synthetic substitution, you set up a rectangle here, but the first thing you need to do is make sure there's no gaps. So let's make sure there's no gaps in our equation. The highest power is 4, then next power is 3, and then we would look for squared. There is no x squared, so it has a gap for the x squared. It does have x to the power of 1, and then it has your constant, which is x to the power of 0. So we need to make sure we fill in our gap. So I'm going to rewrite this equation, and I'm going to fill in the gap for the x squared. So 2x to the 4th minus 5x cubed plus 0x squareds minus 4x's plus 8. Now, the thing that we're synthetically substituting is 3. So that's where I'm going to get the 3 for the thing that I'm going to do in a minute. So what we do when we do synthetic substitution is we set up this rectangle, and then we copy into the rectangle all of the coefficients. So we need the 2, the -5, the 0, the -4, and the 8. And then we need the 3 in front of this box out here. So 3 there. And then the first step before we start the process is to drop down the first lead coefficient out on the bottom there. So now to do the synthetic substitution, we're going to multiply in and add to get out. So 2 times 3 is 6, and then 6 plus -5 is 1. 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. -4 and 9 is 5. 5 times 3 is 15. 15 and 8 is 23. So we get 23 when we do that synthetic substitution there. When you're doing synthetic substitution, the last number is your answer. And what this is really, it's a point on the graph. This would be the point 3, 23, if we were to be graphing it, or just so you can see that this actually has some meaning behind it, it would be the point 3, 23 on the graph. Or if you plug in 3 for x, you get 23, is what this is doing.